Hello, you're welcome once again to Grandelve Tutorials. We try to remind you that in our previous video, we promised proving to you why 2 log 1 over q base 1 over p is the same as 2 log q base p. However, we think it would be better we start by showing to you why log x base 1 over p is also the same as negative log x base p. We believe that if this understanding is so clear to our viewers and subscribers, it will then be easier for us to show to you why 2 log 1 over q base 1 over p is the same as 2 log q base p. So we entreat our viewers and subscribers to give us our full attention as we show that log x base 1 over p is the same as negative log x base p. Thank you. Okay, so how do we show that log x base 1 over p is the same as negative log x base p? As there are so many ways of doing this, let's then try to see if we can represent the expression log x base 1 over p by a variable. Let's say y. So let's start by saying that y is equal to log x base 1 over p. That is, we are representing the expression s log x base 1 over p by the variable y. Okay, in this form, it will then be easier for us to convert this from logarithm to exponential form. So let's start by writing the log in exponential form. Doing this with our technique in logarithm and indices, we believe it will be okay for us to write s to be equal to base 1 over p exponent y. That is, to write this log expression in exponential form, the base becomes the number and the subject of the equation becomes the exponent, as the log number x becomes the subject. All that we are doing is trying to write the log expression in exponential form. And so if you have challenges on this, we advise that you revise your notes on writing logarithms in exponential forms. However, if you have issue with that, you can also tune in both sides and we take you through step by step how to write logarithm expressions in exponential form like this. Okay, so now that we've been successful in writing the log expression in exponential form as s equal to 1 over p to power y, we move on to say that this implies that we can also to write 1 over p in exponential form. 1 over p is a fraction and we can write it in exponential form as p to the power negative 1. As we know that 1 over 2 is the same as 2 to the power negative 1. Okay, so 1 over p is now written in exponential form as you can see here. If this is okay for us to understand, then it wouldn't be difficult for us to understand that once we have two exponents here, we can easily multiply them. That is to say that negative 1 times y will give us negative y as exponents of the p. Now, the simple equation we have now is s equal to p to the power negative y. Before we can move on, we need to consider this. What about trying to take logarithm base p at both sides of the equation? In doing that, we can be successful in bringing the y, which is now an exponent, down as a simple number. In that sense, we can then be successful in making it the subject. That is our main aim. Our main aim is trying to make y the subject of the equation again. All right, so let's take logarithm base p at both sides of the equation. Which equation? The equation s equal to p to the power negative y. So you consider log with base p at both sides of the equation. Taking log base p at both sides of the equation will give us log x base p, that's to the left, and to the right we have log p exponent negative y base p, as you can see here. Looking at the right hand side, you can see that we have log p exponent negative y base p, which means that we can use our exponential law of logarithm at the right hand side. Using our exponential law of logarithm at the right hand side will mean that the negative y will then come to multiply the log p base p, as shown in our next step here. That is negative y then comes to multiply log p base p. That is using our exponential law of logarithms. And I believe you still remember your laws of logarithm. So this will be easier for you to comprehend. In that case, in the same vein, you also to understand that anytime that you have log of a number and the base is the same number, that renders us to 1. That is log p base p is 1, just as log a base a is 1, and log 2 base 2 is 1, log 10 base 10 is 1. That one too can be proved. And so if you have any challenge to understand why log of a number with the number being the same base as a log is 1, then you can again in both sides for us to have one-on-one tete-a-tete with you and show to you why it is so. That is to say, this whole expression goes to 1. Hence, our next expression will be log x base p equal to negative y, as we can see, because negative y times 1 is negative y. At this time, just as I said earlier, our main aim is to make y the subject. So if y is negative y, then we can make it the subject now to have our last result as y equal to negative log x base p. Remember that at the top, we said that y should be equal to log s base 1 over p. All right. Y was never part of the proof. We introduced it. So if now we have y equal to negative log x base p, we should represent the y, which we said it is supposed to be equal to log x base 1 over p. We should put this whole expression in place of the y to make sure that our proof is successful. So putting the expression in place of y, we now have the log x base 1 over p equal to negative log x base p as required. Thank you for your time, and if you have any questions on this proof or you have any comments to make, please don't hesitate to inbox us. Thank you.